We look at some methods of entering commands and controlling the precision of variables in MATLAB, in the MATLAB environment and the command window. This is the MATLAB command window. This is the command window. This is the MATLAB prompt. And this is the menus from which new files could be created. The .m files get created by opening a new .m editor and typing the program in there. This is the workspace browser. So let's first look at the format. The command format sets the output format. So format with no inputs sets the output format to the default appropriate for the class of the variable. So for float variables, the default is short format. Short is the default format command option. Format does not affect how MATLAB computations are done. Computations on float variables, namely single or double, are done in appropriate floating point precision, no matter how those variables are displayed. Computations on integer variables are done natively in integer. Integer variables are always displayed to the appropriate number of digits for the class. For example, 3 digits to display the int 8 range from -128 to 127. Format short and format long do not affect the display of the integer variables. So basically the computation happens internally, but the format is just the display of that internally computed variable. So these are the options available in format. Format may be used to switch between different output display formats of all float variables as follows, like this. So format short, long, short E, short G, long G, short engineering, long engineering. So short, format short is scaled fixed point format with 5 digits. Format long is scaled fixed point format with 15 digits for double and double precision and 7 digits for single precision. Format short E is floating point format with 5 digits. Format long E is floating point format with 15 digits for double precision and 7 digits for single precision. Format short G is best for fixed or floating point format with 5 digits. Long G is best for fixed or floating point format with 15 digits for double precision and 7 digits for single precision. Format short engineering is engineering format that has at least 5 digits and a power that is a multiple of 3. Format long engineering is an engineering format that has exactly 16 significant digits and a power that is a multiple of 3. Format may be used to switch between different output display formats of all numeric variables as follows. So format hex is a hexadecimal format. Format plus, the symbols plus, minus, and blank are printed for positive, negative, and 0 elements. Imaginary parts are ignored. Format bank is fixed format for dollars and cents. Format rat is approximation by ratio of small integers. Numbers with large numerator or denominator are replaced by an asterisk. Format may be used to affect the spacing in the display of all variables as follows. Format compact suppresses extra line feeds. Format loose puts the line feeds back in. Let's look at some examples. The default is format short, but we are explicitly showing the format short here. It's an example in MATLAB. Format short pi with single precision. So format short applies on the pi, which is a transcendental number, which is stored in MATLAB memory. And the single precision applies the single precision algorithm at format short at this level, between 4 and 5 digits after the decimal. Likewise, format long is chosen for the same number pi, single precision to be applied to the long format. So the single precision algorithm works at these digits for the pi variable. Pi is a constant for the pi constant. Let's look at the factorial command. Factorial 2 is 2, factorial 10 is accurately computed. Factorial 12 is once again accurate. Factorial 13 is the smallest factorial, which is expressed in the exponential form. So until factorial 12, MATLAB computes the accurate value. From factorial 13, it shows the exponential format for the factorial of 13 and higher than 13. Factorial 170 is the largest factorial MATLAB can compute. Factorial 171 is larger than the largest MATLAB can accommodate, so it returns inf. So factorial 171 is larger than 10 to the 300 plus that MATLAB can accommodate. So that's why factorial 171 is an inf. So if I use format short for factorial 170, I have this displayed. Remember what factorial 170 was? The largest factorial that MATLAB can show. MATLAB can approximately compute. So if I apply format short to factorial 120, the precision applies to 4th and 5th digits of factorial 170. If I use format long, the precision is at these digits, just like it happened for pi in the previous example. The gamma function is a generalization of the factorial function. So gamma of x returns the gamma function of that x argument. X must be real in the MATLAB syntax. In the syntax of GAMMA function, the gamma function is defined like this: integral 0 to infinity t to the x minus 1 into e to the minus t dt. So it interpolates the factorial function. It is described as a generalization of the factorial function. When the argument is an integer, the gamma n plus 1 is n factorial, and this can be easily shown. New functions may be added to MATLAB by using the function command. New functions may be added if they are expressed in terms of other existing functions. The commands and functions that comprise the new function must be put in a file whose name defines the name of the new function, with the file name extension of .m. At the top of the file must be a line that contains the syntax definition for the new function. For example, this is an example. So stat is the new function being defined. It returns two variables, stdev and mean, and they're defined in this format in the body of the script of the function command of the new function stat, which is being defined here. This is the example. So new MATLAB scripts may be created by using the new script option. So where we also have sub option to choose between creating a script or creating a new function. So the function extensions are .m or some other compatible format. So this is the menu through which we can create new functions or new scripts. And commands which cannot be entered on the command window have to be scripted using the .m file. So programming, forming of for loops, while loops, and all of the logic of strings and everything goes into code which is written in the .m file of MATLAB. A .m file can be created by opening a new script, choosing whether it's a script file or a function file, and accordingly scripting the logic into that .m file.